Okay, good afternoon everybody. In the last class, okay, again I will take the recap session for 5 minutes, okay, and then I will start with the further explanation of the surface measurement. And in the last class, we have learned about again introduction, definition, okay, what are the contents of the surface measurement. In that introduction, definition, symbols used in the surface finish, and analysis of traces, and Taylor-Hobson's Telesur, simple numerical law on surface roughness. Okay, and in the introduction you have learned, okay, what are the functioning of the machine parts, okay, load carrying capacity of the part, tool life, fatigue life, and all those things, okay, introduction. And then in the introduction again, root of any surface irregularity acts as a sharp corner, that is your hills and valleys, okay. So we'll come into picture, okay, for the part failure, okay. And in the introduction again, so the number of irregularities, large number of irregularities, okay, how it is proportional to the surface area, okay, in the contact, that we have learned. And the surface texture is okay. Next, why, okay, the surface roughness is required, okay, so those things, okay. And the different types, okay, the causes, okay, of the surface irregularities, okay, so those you have seen, okay, what are the factors influencing on the surface roughness, that you have seen. And in the introduction again, okay, so if the valleys, okay, appears as close, okay, like that is a difference between the two hills and valleys, okay. If it is close, then we are calling it as a rough surface roughness, and if the valleys are far apart, then we are calling it as an imperfection or a texture or waviness, okay, secondary texture or waviness. So that you have seen. And so why, okay, what is the causes, that you have seen, that is the feed, okay, in the cutting tool, okay, tool and cutting action, okay, vibrations, imperfections, all those particular things will affect the tool life, okay, or the surface roughness. Next, you have seen the meaning of surface texture and some definition of that, first order, second order, third order, and fourth order, okay. And in that again, okay, you have seen the meaning of the irregularities, okay, in the group, how it is the irregularity is considered as wavelength, okay, of periodic character, okay. So those particular things you have seen. And then third and fourth order also you have seen. And this figure you have seen, that is the irregularity, that is lay, roughness, height, okay, scratch, okay. And the how you are going to mention in the drawing, that you have seen. So this is the roughness height in micron inches, okay, waviness height, direction of the lay, okay, those particular things you have seen. And you have seen the roughness average value, okay, in the micron meters or micro inches. So for different processes, the processes I have explained in the last class, okay. So next is the lay symbol you have seen in the last class, that I have explained these particular things, that is the example showing the direction of the tool mark, okay, and the meaning of that you have seen. And then next is surface roughness. Today I will explain this, okay, what are the different surface roughness, roughness, what is the surface roughness and what is the terminology of that. So here in this particular case, okay, the surface roughness, the several kind of departures are there on the surface, and these are due to various causes. So cause, okay, any cause, and just in the last class I have explained about one cause is the feed mark of the tool, feed, okay, whatever the feed we are giving, so it will affect the surface roughness of that particular part. Or cutting speed, you take the parameter, second parameter as the cutting speed, okay, first parameter is the feed, second parameter is the cutting speed. So similarly flushing, okay, if it is the flood coolant, if it is the other type of coolant system, any cutting speed, feed, and depth of cut also one parameter. You take any parameter or temperature as a parameter which will cause these particular surface departures, okay. So second point, the roughness or a texture in the form of succession of the minute irregularities is produced directly by the finishing process employed. Whatever the finishing process is employed, okay, that is a direct succession, texture in the form of succession. So whatever the succession is there. So initially if you go for the semi-finish machining, the surface texture is very high. Okay. And if you go for the finish, as the minute irregularity is produced directly by the finishing process, minute, very minute, when you go for the grinding process or honing process, at that time the surface irregularities are very minimum. So as the roughness or a texture in the form of succession of minute irregularities, okay, minute irregularities, it is produced by the finishing processes, okay, like your grinding process or honing process or other processes or CNC process. Next is the third point, the characteristics roughness produced by the tool is not the only cause of roughness in case of machining operations, but more openly spaced component or roughness are also produced from faults in the machining operation. So here what these particular sentences say, the characteristics of the roughness. What are the characteristics of the roughness? So one characteristic is your RA value, second characteristic is your RQ value, if third characteristic is your Z value or SM, okay, or mean the spacing, okay, between the two hills and valleys, okay, or else you take the peak count of the distance between the two peak counts, okay. So those particular things, okay, those are the characteristics. So the characteristics roughness produced by the tool, okay, whatever the cutting tool is, which type of cutting tool you are going to use for the type of the operation. Say like I am using for the turning operation on the CNC machine, I am using the different types of tools, like say CNMG tool I am using, TNMG tool I am using, WNMG tool I am using. It depends on which operation, whether you are using the CNMG tool for the finishing operation or WNMG tool you are using for the finishing operation. That is very important. So here, that's why I have told which characteristics. Say if I am measuring the RA value, okay, then it is produced by the tool is not the only cause. So one cause is tool, second cause it is not only that the tool, okay, or the tool, if I am selecting the tool, okay, then that is the first cause. Say that is the first cause, then the tool whatever I am using, it depends on which type of how much depth of cut I am going to give, okay. The tool is one important thing, that is the one parameter. Second parameter I am using, say, so first parameter is a tool. Tool means what? The material of the tool, which type of material, whether I am using the carbide material or tungsten carbide material or PCB tooling, okay, polycrystalline PCD tooling, polycrystalline diamond tooling, okay, for which operation, okay, that is operation wise. Second thing is the cutting parameter what I am setting on the machine, so that is cutting speed, feed, depth of cut. And then the third parameter, if I am selecting fourth parameter is the radius, nose radius of the tool, okay, for say R1, R2, 0.8, R.8, R.4, R.2, okay. So that's why in this particular line they have given characteristic roughness produced by the tool is not the only cause of roughness in case of machining operation. That is not the case of only a tool will not, the other parameter which is affecting the characteristics, okay, there is the cutting speed, feed, depth of cut, or tool nose radius, or the cutting tool, which type of tool, so the type of the material, the tool instead of carbide, which type of material we are using, so those are also having the effect on this particular characteristics, okay. But the more openly spaced component or roughness are also produced from faults in the machining operation. Yes, more openly spaced component, okay, how you are going to hold the component, okay, how much rigidly you are holding the component. So that is with the help of fixture, okay, so to avoid the vibrations, okay, to avoid the chattering mark of the tool, okay, once the machining started. So that is this more openly spaced component or roughness are also produced from faults in the machining operation. What are the faults? Okay, so that is dampers are not properly proper in the machine. Okay, so which will absorb the vibrations. Okay, so dampers, we are providing the dampers to the CNC machines. So those machining, it is the faults in the machining operations. So that is a machine fault. Okay, if the table is not rigidly rigid, then also the chattering mark or vibrations, small vibrations will come. Okay, the other thing is if your spindle is not rigid, then also the chattering mark will come. If you are using, okay, say tool of diameter, say instead of 20 mm, if you are using 10 diameter and you are giving maximum depth of cut, in that particular case also the chattering mark or the vibrations will come. So that is the faults in the machining operation. Okay, and the different, other than this, we are setting the different parameters. Okay, for specific tool we are using, we are selecting the specific parameters. Okay, so the tool life is also depends on the parameter what we are setting on the CNC machine, okay, or a machine, different machine tool, either it is a conventional machine or a CNC machine, okay. But whatever the characteristics, yes, we are setting the parameter, we are writing the program, okay, and we are loading that particular program in the controller system, and then we are doing the operation, machining operation. But whatever the characteristics, okay, what is my output characteristic? Output characteristics is your surface roughness. Now how you are going to measure that particular surface roughness? What are the causes? Okay, what are the effect of these particular parameters on this particular characteristics of roughness? So that is very, very important. So the one more characteristic which is affecting the surface roughness is this. Okay, so there are faults in the machining operation. Next is, thus the complete study of surface roughness, it is essential that measurement and analysis of all the component elements and an assessment of the effect of the resulting combined texture be made. Now in this particular section, what they have given, how you are going to study that particular surface roughness. Once that machining, yes, I want to do some machining, okay, so like one bar is there of EN8. Okay, I want to turn that particular, I want to do the facing operation and turning operation of that particular bar with some RA value. If it is specified on that particular drawing, I am doing, okay, I am just writing the program for the facing operation and I am writing the program on the machining operation, that is the turning operation. Okay, and then whatever the cutting speed, feed, depth of cut, okay, it is depends on which type of tool you are going to use to remove that much stock of the material from the bar stock. Okay, so it is very essential that the selection of the tool is very important, first important thing. Second important, according to the tool, okay, see, according to the surface value you are selecting the tool, according to this particular tool you are selecting the whatever the recommended cutting speed, feed and depth of cut you have to set on the machine. Okay, so that is very important. So the complete study of this surface roughness is one essential. Okay, and it is essential that the measurement and analysis of all the component elements. So these are the component elements. That is the cutting tool is the one component element. Second one is the cutting speed, feed, depth of cut. These are the component elements. Okay, assessment of that, study, that is effect of parameter of cutting tool. That cutting tool is a one parameter. Different cutting tools, say like carbide tool, polycrystalline diamond tool. Next is your CBN tooling, cubic boron nitride tooling. So which type of tool you are going to use for that specific material? Let's say if I am using EN8, then carbide is okay, recommended. Okay, polycrystalline diamond is also recommended and CBN is also recommended. But the thing is, the cost of the tooling is very, very high. So that's why instead of that we are using carbide tool. Okay, but the analysis, measurement of that particular tool, analysis, whatever you are doing, which are the parameter effects which are directly significant on the machining characteristics. Machining characteristic is your roughness value, surface roughness. How you are going to analyze, how you are going to do the analysis, okay, using this, okay, with some that is the individual effect, okay, that is parametric effect, that is which parameter is affecting more, okay, on the roughness value, whether it is cutting speed is affecting or feed is affecting or the depth of cut is affecting or the cutting speed and feed, okay, both are affecting, or that is the interaction of the both, the cutting speed and the feed, the interaction of the both is affecting the characteristics, or the cutting speed and feed and depth of cut is affecting, or cutting speed and depth of cut, which interaction effect of these two are affecting, significant or significantly affecting the surface roughness value. So that is your analysis of the components elements, okay, and an assessment of the effect of the resulting combined texture, okay. So affecting, this is the assessment what we are doing, okay, effect of the resulting combined, that is your cutting speed, feed, depth of cut, anything combined effect, okay, on the texture be made. All this being very difficult. Next point, all this being very difficult and tedious job, yes. Tedious job is what? Why? Every time for every component, say like there are different materials, okay, say like your cast iron, I'm doing the machining of cast iron, I'm doing machining of the mild steel, I'm doing the machining of the brass, the bronze, okay, so ferrous and non-ferrous materials. So for ferrous material and non-ferrous material, I am setting the different parameters, recommended cutting speed, feed and depth of cut for different material also mentioned, okay, in the for the tools, okay. So but this is very difficult and tedious job. Every time you have to set the parameter and you have to analyze the RA value. In practice, all that is essential is that a practical method of assessment be followed. So that is why every time the practical method. So usually whenever you are doing some machining on the say cast iron part, like say a hub part, but in that particular case, okay, for the cast iron part, recommend cutting tools are there. Okay, tool inserts are there for the CNC machine. So here, essential that the practical method of the assessment to be followed. Practical method, yes, for that particular cast iron, yes, you have to use this type of insert, CNMG insert for roughing and finishing operation. For smooth finishing operation or the RA value which is less than 6.3 micron meter, then you have to use WNMG tool. So that is the practical method, okay, which type of tool you are going to use to achieve that RA value. So that is how you are going to assess with the help of practical method, okay. The result of which can be readily compared with the specified requirement of the quality. So whatever the quality is mentioned in the specific drawing, okay, say RA value 6.3 micron meter. So that for that the type, whatever the different methods, okay, method in the sense the parameter you are going to set, the tool you are going to set, okay, and what are the levels, which type of level you are going to set on the machine, okay, that is very important, which is compared with the specific requirement of the quality, preferably on the numerical basis, okay, say like 6.3 micron meter, the numeric, 3.2 micron meter, 0.6 micron meter, okay, so like that. So that is a numeral basis, okay. Next, the measurement of surface roughness, okay, this particular paragraph, okay, poses a problem in the three-dimensional geometry, but for the specification purposes, it is better to reduce it into two-dimensional geometry by confining the individual. So usually we are not going for three-dimensional the measurement, we are going for two-dimensional measurement for the surface roughness, okay. So usually why? Because the whatever the measurements we are taking in the two direction, we are not taking in the three-dimensional space, workspace, okay. So either it is in the X direction, whether it is in the Y direction, okay. You will come to know what is the hills and valleys, how much hill and valley will come, what is the wavelength of that particular thing will come, okay. So that's why we are taking always in two-dimensional geometry by confining the individual measurement to the profiles of the plane section taken through the surface. Whatever the section is there, I am taking one section along the x-axis, one section I am taking along the y-axis, okay. So x-axis section and y-axis section, that is very important, okay, of the surface. The direction of measurement is usually perpendicular to the direction of the predominant surface marking or a lay. So whatever the lay is there, okay, so we are taking always perpendicular with respect to the lay. Whatever the cutting lines are there, okay, the surface, okay, the lay is there. So if you see this particular figure, you will come to know the direction of the lay, okay. So here the direction of the lay in this particular direction, that is in y direction. But whenever we are taking the reading, we have to take the reading like this, okay. So this is the length to be measured. If I want to take this particular length, this should be perpendicular. This is perpendicular with respect to your direction of the predominant surface pattern or a lay, okay. So it should be perpendicular. So same thing is given here, okay. So two-dimensional in the sense, so if you take the section here, so if you take the section along the x-axis and along the y-axis, you have to take only two sections, x and y section, and then the measuring pattern should be like this. It should be perpendicular with respect to the direction of the lay, predominant surface pattern or a lay, okay. So that is given here, okay, in the surface roughness definition. Next, Surface roughness is concerned in this particular section. They have given surface roughness is concerned both with the size and shape of the irregularities. Size and shape. So in the if you see this particular surface irregularities, okay, size and shape, okay. So here, sorry, yeah. So size of the size and shape of the irregularities. So this is the size, one size, this size, second, third, fourth, like so and so forth. So size and shape, how that particular shape is, irregularities, okay. The shape of the irregularity that you have to see. So this is the one shape, okay. Okay, the shape is like this, the irregularities, okay. In the last class I have explained this, okay. Irregularities, the primary texture, waviness, surface profile, all those, roughness, spacing, waviness spacing, primary texture, okay. So this is a secondary texture and this is the error of form, okay. So that is this, okay. The size and shape of the irregularities, okay. So the different forms of the terminology, okay. Real surface, geometrical surface, effective surface, surface texture. Real surface, okay, I have explained, okay, is a surface limiting the body and separating it from the surrounding surface, okay. Geometrical surface is the surface prescribed by the design or by the process of manufacture, okay, neglecting the error, form and surface roughness, okay. That is a geometrical surface, okay. Effective surface is the close representation of real surface obtained by instrumental means, okay. So whatever the real surface is there, instrumental, that is a telesurf what we are using, okay, to measure the surface roughness. So that is by instrumental means, okay, close representation of the real surface. Surface texture, repetitive or random deviations, whatever the deviations, repeated or random deviations are there from the nominal surface, that actually which is in the form of different patterns are there, okay, of surface, okay, roughness, waviness or lay or flaws, okay, that. And then the surface roughness, okay, it concerned all those irregularities, okay, which form surface relief, okay, and which is conveniently defined within the area where deviations of form and waviness are eliminated. So form and waviness here in this particular roughness are eliminated in this particular surface roughness, okay. So but you have to consider all the irregularities, okay. Primary texture roughness, it is caused due to the irregularities in the surface roughness which results from the inherent action of the production process, okay. These are deemed to include the transfer feed marks, okay. So whatever the feed marks are there, transfer feed marks are there while machining, okay. Whatever the irregularities are there within them, so that is your primary texture or a roughness what we are calling, okay. Secondary texture waviness, it results from the factors such as machine or work deflection, okay, vibrations, chatter, heat treatment, wrapping of strains, okay, all those particular, these are called waviness, okay. These are from the factors of the machine, okay, that is the work deflection, if the work part is not hold properly, so because of that, vibrations of the machine tool, chattering mark because the tool is not hold properly in the adapters, okay, heat treatment or warping strains, okay, heat treatment, after heat treatment process, okay, those particular the waviness will come, okay. The strains, okay, so that waviness is component of surface roughness upon which the roughness is superimposed. So if superimposed of the roughness, okay, on that component. So this is the drawing, okay, primary texture roughness, texture waviness. So if you see this particular primary texture, this is the roughness, and here if you see the bottom point and the topmost point of that particular hill and valley, that is your called a waviness or a texture. Primary texture is your roughness, okay, that is a hill to this distance, okay, that is this particular distance from here to here, okay. So but here the very valley, okay, that is the depth of the valley and the height of that particular the texture, okay, that is the called is the texture, okay, that is a hill and valley, okay, crest point and the root point of that particular thing. Okay, next is the flaws. Flaws are irregularities which occurs at one place, okay, or at relatively infrequent or widely varying intervals, okay, in a surface, like scratches, cracks, randoms, blemishes, etc. So usually the scratches will appear on that. So it is also a irregularity. Cracks, that is also whatever after heat treatment, some because of the heat treatment, what happens, the cracks will propagate. Very minute cracks will be there, but it is not visible to the eye. So that those particular cracks, random blemishes, okay, will occur on that particular surface. So those are called the flaws. Okay. Next is the center line, the line about which the roughness is measured. So how we are going to measure that particular the roughness. So on the center line we are measuring that. What is the lay? It is the direction of the predominant surface pattern ordinarily determined by the method of production used. Which type of method the production, whether you are going for the milling operation, whether you are going for the turning operation, okay, or whether you are going for the grinding operation, it is depends on that, okay, the method of production we are using. So the lay depends on that. Next is transferring length. Is the length, what is the transfer length? Okay, so here if you see transfer length, okay, okay, waviness spacing, roughness spacing, okay. So transferring length of the profile necessary for evaluation of the surface roughness parameter, transfer length, okay. So traversing length may include one or more sampling length, whatever traversing length of your probe, okay. So which that is the length, how much you are going to take, whether you are taking 1.2 mm traversing length or 1.4 mm, 2.4 mm, 2 mm, okay, 0.8 mm, that is the transfer length of that particular probe, okay, which you are going to evaluate the surface roughness parameters, okay. So traversing length we are setting on that particular telesurf machine, okay. So that is the length of the traverse of that particular probe, okay. So next is the sampling length. So it is the length of the profile necessary for the evaluation of the irregularities. That is the profile. That is the length of the profile. How much is the length of the profile you are going to take to evaluate the irregularities to be taken into account. So that is what we are going to the cutoff length. Okay, traversing length, it will travel more, but the cutoff length is okay. It will go and it will stop there and it will come back. So the probe will come back. So that is the cutoff length. Okay, in the regard to the measuring instrument. Okay, so that is your sampling length. So how much you are going to take. Traversing length is bigger, sampling length is the shorter, okay. So here just observe here the evaluation length, okay, sampling length is L, okay, small lengths, okay. So this is a total traversing length is this much, total traversing length is this much, okay. Here evaluation length, I want to evaluate from here to here, but I want to split this. Sampling length is 1, 2, 3, 4, 5 samples I want to take, okay, with and the average out of that those particular sampling I will take, and then I will I will measure the surface roughness of that particular value, okay. If you see the sampling length here, okay, so this is sampling length, okay. So here sampling length L, okay. Now only I am just concentrating on this particular part now. So sampling length is, so this is a sampling length, okay. This is along y-axis, y minus, y plus positive axis, this is a 0, about the 0. This is the effective profile, okay. This is the effective profile, and this is the maximum height of the irregularity. So this is the maximum height, whatever the height is there, this is the maximum height of the irregularity. This is the mean line, and this is maximum height from the root to the crest part, okay, or the valley to the hill, the highest point of the valley to the highest point of the hill. So that will give the effective profile, that is the maximum height of irregularity, okay, what we are taking, okay. Next terminology, okay, in the terminology, mean line of the profile is the line, okay, this is the mean line. This is the mean line, 0, along the x-axis. So this is the mean line. So what is the mean line? Mean line of the profile is the line having the form of geometrical profile and dividing the effective profile so that within the sampling length, the sum of the squares of distances. So that is y1, okay. So this distance is y1, this is y1, okay, all those distances y1, y2 up to yn. So this is distance y1 in this direction, Okay, so that is the direction of that particular up to yn, square of distances between the effective points, and the mean line is a minimum. So this is the mean line. So this is the 0 to this x is the mean line. Okay, this is the xn, x1, x2, x3, x4, x5, x6, like so and so forth, x11, x12, like that. This is about the x-axis. So similarly about the y-axis, what is the height? Okay, that is y1, y2, y3. So up to the square, the sampling length, the sum of squares of the distances. Okay, that is y1 up to y1 effective points, and mean line is a minimum. Center line of the profile is the line. Okay, center line. Okay, so center line of the profile, okay, is the line parallel to the general direction of the profile, for which the areas embraced by the profile, okay, and below the line are equal. So whatever it is embraced by the profile, okay, that is the direction of the profile, okay, and below the line are equal. So below that whatever line are, those all are equal when the waveform is repetitive. If the waveform is repetitive, then only we are taking that, okay, center line of the profile. The mean line and the center line are equivalent. So in this particular case, this whatever 0 to x is there, that is the mean line, which is equivalent to the center line when the waveform is repetitive. That is very, very important here. Okay, this is very, very important. Waveform is repetitive. Okay, next, spacing of the irregularities. This spacing of irregularities. So maximum irregularity is this. Whatever the spacing is there, this is spacing, this spacing, this spacing, this small, and again here bigger space, smaller. So spacing of the irregularities is the mean distance between the more prominent irregularities. More prominent. So always repetitive. More prominent irregularities of the effective profile. Okay, that is the spacing of the irregularities. Okay. So here spacing of the irregularities. That is here. This is the spacing, as I have told. Okay. So now, why this particular spacing of irregularities is very, very important is, it is because of the information is useful for measuring the wearing, okay, in of surfaces in relative motion. Wearing in of surfaces in relative motion, and assessing the electrical and thermal conductivity between the surface in contact. So electrical conductivity and thermal conductivity between the surfaces in contact, whatever it is there, we are assessing that. Okay, when the wearing of surface relative to the motion, okay, relative motion. Okay, and here irregularity spacing, okay, and height parameter used in combination are valuable for sheet steel application and for friction and lubrication studies. So for the lubrication and friction studies, these sheet steel applications. Okay, why these particular irregularity spacing? This particular spacing, why this particular spacing is important, that they have mentioned here. And height parameter, that is x1 and y1 height, whatever the x1 to x1, x2, x3 to xn, and y1, y2, y3 to yn values are there. So those particular spacing and height parameter used in combination, that is x1, y1, x2, y2, like that combination, it is valuable for sheet steel application and friction and lubrication studies. Okay, so that is here how you are going to arithmetically solve. So arithmetically mean deviation from the mean line of the profile. Okay, arithmetical mean deviation from the mean line. Okay, mean deviation is how much? So this is a deviation. So in x-axis this is a deviation. Sorry, this is y-axis. This is a deviation. This is x-axis deviation. This is a y-axis deviation. X and y. Okay, so deviation from the mean line of the profile RA is defined as the average value of the ordinates y1, y2, yn. So this is the average. We are taking the average value of that. That's why I have told we are not taking individual. We are taking all. We are measure all, and we are taking the average of those particular x1, y1 values. Okay, in array. The ordinate are summed up with considering their algebraic sign. Array is equal to 1 divided by n. Okay, so 0 to 1 into mod of y into dx. Okay, so here what is n? N is the number of divisions over the length, whatever the length is given. So how many divisions you are going to make? So that is the number of divisions over the length L. Okay, so RA is how you are going to calculate. So sum of 0 to n, that is mod I divided by n. Okay, so this is how we are calculating the arithmetical mean deviation from the mean line. So next is the 10 point height of irregularity is Rz. How you are going to, that's why I have told the roughness characteristics are Ra, Rq, Rz, Sm and Pc. Okay, so in that 10-point height of irregularities, that is Rz, okay, it is defined as the average difference between the 5 highest peaks. Okay, 5 highest peaks we are taking. So here if you see, this is the peak, 5 highest, 1, 2, this is 3. So similarly 4 and 5 here. So highest 5 peaks we are taking, highest values 1, 2. In this particular case 2 are there. So similarly here, average of the difference between the highest 5 highest peaks and 5 deepest values within the sampling length, whatever it is there, this is the sampling length. Okay, this is the sampling length. Here highest hills 1, 2 and 3 are there. So here 1 and 2. So total 5 in this sampling length of from here to here, we have 1, 2 and 3 highest, and this is the deepest valley 1 and 2. So here 2, this is 1. So 2 valleys are there, deepest valleys are there in the sampling length. Okay. Length measured from the line. So whatever the we are taking from where, okay, we are starting, that is from there, parallel to the mean line and not crossing the profile. So it is not crossing the profile. Whatever profile we are selecting, it should not cross the profile. Okay. So here Rz value is mod of R1, R3, R5, R7 and R9. Okay, plus see the R2. Okay, that is R2, R4, R6, R8, R10. So total 5 we are taking. So average difference between the 5 highest peaks and 5 deepest valleys. So deepest value is this R2, R4, R6 and R8 and R10. So 5 highest peaks are R1, R3, R5, R7 and R9 divided by 5. So 5 total we are taking. Okay, Rz. So this is how we are calculating Rz. Okay, that is the 10-point height of irregularities, Rz. So the line, if you see the sampling length, line parallel to the mean line. So this is the line parallel to the mean line. So here they have given, they have shown this is the R1. From the mean line we are measuring this particular height, that is a hill. Okay, highest hill point. Okay, this is R2, this is a valley. This is R3 again hill, this is a valley. This is R5 hill point, R6 is a valley point, R7 is the highest point on the this thing valley hill. This is R8, R9. So similarly here, the height. Okay, 5 highest peaks they have taken. This is the deepest valley they have taken. Okay, so R6, R10. Okay, next is maximum height of irregularities. How you are calculating the Rmax? Okay, maximum height of irregularity is defined as the distance between the two lines parallel to the mean line and touching the profile at highest points within the sampling length. So here two lines we are drawing. Okay, which are parallel with respect to the mean line. Okay, and whatever the mean line, okay, the two lines parallel to the mean line and touching the profile at highest point. So those two lines, whatever we are defining those two lines, which touches the highest, the peak point and the deepest, that is touching the profile at highest point within the sampling length, whatever the highest point is there, so that deep valley and the height. Okay, so those particular things, that is called as a maximum height of the irregularity. So terms used for describe the surface roughness, again here if you see the average peak to valley height, Rz. Okay, average peak to valley height. So here average peak, okay, to valley. So from here to here, from here to here, from here to here. So if you see this particular thing, okay, so highest peak, deepest valley, highest peak, deepest valley, and deepest valley, highest peak, like this. So that whatever it is there, that is called Rz. Okay, average peak to valley. Okay, height Rz. So that is average of single peak to valley height from 5 adjoining sampling length, 5 adjoining sampling length. So here average peak to valley height, average peak to valley height. Okay, average of single peak, whatever to the valley. So single peak to the valley is this, single peak, okay, to the valley. Okay, now here sampling length we have taken this much. So similarly n number of samples we are taking, so those many sampling length here mentioned over here. Okay, that is this. Okay, 5 adjoining sampling length. So here we have taken only one. So here only one sampling length we have taken. So similarly adjoining sampling length we have to take. Okay, and then you have to calculate the Rz value, sampling length. So RT, what is RT measurement? It is the maximum peak to valley height within the assessment length. Whatever we want to assess that particular length. Okay, so that is the peak and to the value RT measurement. What we are calling it is the RT measurement. So highest peak to valley height. Okay, within the assessment length. Okay, this measurement is valuable for analyzing finish to provide guidance for planning subsequent metal cutting operations. So this whatever the maximum peak and valley height is there within the assessment length, that is very important for providing the guidance. Okay, so the how you are going to set that particular parameter in the cutting operation. Okay, so average wavelength, how you are going to calculate? So sorry. Yeah. RT measurement, average wavelength is equal to 2 pi into RA. Okay, so RA is the roughness value. 2 pi into RA divided by mean slope. Whatever the slope is there, that is the mean of that particular slope. Whatever it is there, it will give the average wavelength of that particular part. So today I will stop here. Till now we have whatever in this particular class we have seen. Okay, what is the surface roughness? Definition of the surface roughness. Okay, and then the terminologies of the surface roughness, that is real surface, geometrical surface, effective surface, and surface texture. And then surface roughness, what is surface roughness, what are the primary textures in the surface roughness, secondary textures we have seen. This is the figure which will explain everything. What is the primary texture is called the roughness, texture is called the waviness. Okay, so roughness spacing, how much is the roughness spacing, waviness spacing, surface profile. Okay, lay direction of the dominant pattern, primary texture. Okay, secondary texture, it is called waviness. Okay, the error of the form that you have seen, flaws, center line, what is center line, what is flaw, what is the lay, traversing length, which is the traversing length, which are the sampling length. Okay, so this is the sampling length. Okay, so those particular maximum height of irregularity, and then the mean line of the profile, center line of the profile that you have seen. Okay, and then spacing of irregularity, how you are taking. Okay, for the arithmetical mean deviation. Okay, to calculate this array value of the profile, and then the equations. Okay, to calculate the 10-point height of irregularities. Okay, to calculate RZ. Okay, this particular figure will explain about the sampling length and line parallel to the mean line. Okay, these are the line parallel to the mean line that you have seen. Maximum length of irregularity, that is very important. Okay, so next is the terms used to describe how you are going to describe the surface roughness. Yes, average peak to valley height. Okay, that is RZ. What is RT measurement? Then average wavelength. Okay, how you are going to calculate. So these are the things. Okay, you will explain. Okay, about the surface roughness. Okay, in the next class again I will explain. Okay, some more terms about this particular how you are going to describe that surface roughness value. Okay, so today I'll stop here. So here in the roughness, surface roughness, the content, okay, the introduction, still we are into the introduction and definition of those particular RA, RQ, RZ. Okay, next we are using the symbols, which type of symbols used for surface finish. Okay, so those you will see, analysis of how you are going to trace that part. Okay, analysis of tracing, Taylor Hobson's Delisser. Okay, about that, simple, numerical, and surface roughness. Okay, so some numericals are there, but we'll see if it is there in the book syllabus, then I will explain about those particular things. Okay, so today I will stop here. Okay, so thank you. So if you have any the questions about this particular surface roughness and the other thing, okay, about the subsections, whatever I have explained, if you have any query, just mail me, or there is a WhatsApp group, so you just ask the questions, okay, in the WhatsApp, through WhatsApp media, the WhatsApp and the email, okay, through email. Okay, I will just explain once again. If you want anything, okay, if you want to explain, if I want to explain once again, so I will explain those particular things. Okay, just if you have any questions, okay, then I will explain once again. So today I will stop here. Okay, thank you.